But let's introduce our friend and dedicated member of the ag community, Emerson Nafziger. He grew up on a farm in northwestern Ohio and earned degrees in agronomy from Ohio State, Purdue, and the University of Illinois. He joined the U of I faculty in 1982 and spent his career working on crop management, in more recent years, soil fertility. He officially retired at the end of 2017, but remains very active in research and extension. Emerson Nafziger.
Well, good morning. Thanks a lot for having me here. Not everything I'll talk about this morning is going to be NREC funded. I'm still on a project with Caillou Guan. You'll hear from him this afternoon talking about nitrogen. And so it's still a topic of great fascination for a lot of us. And, it's sort of where environment meets economics meets agronomics. And that intersection is a really interesting place to be. So this is supposed to be sort of a what's next for nitrogen. There's supposed to be a question mark there. But I talked to Howard Brown this morning, and he said we should be visionaries once we get to retirement. And I thought, well, is that a prophet or what is it exactly? I'm not going to try to do very much of that today, but talk a little bit about where we were at, some of the things we've seen come and go, maybe just looking a little bit to the future about what we're going to be doing with nitrogen 10 years from now or 20 years from now, because it's going to remain a large issue for sure. And, whether it's high-priced or low-priced, it's going to be an issue because they both bring their set of challenges. I wanted to throw this in. I'll talk a little bit about this last year. In the program there, it says I'll talk about this last year. I'll talk about it just a little bit because it's another example of an unusual year. I really wanted to show you this more or less to tell you what some of the new tools are that anybody can use. These are free and available to the public. And this is partly a NASS project and also geologists and crop chasma, which is written up there in the upper right. If you want to search for this, this is something you could spend a whole afternoon on. And it's a website where it actually gives you daily or weekly scans of crop canopy development in the crop during the season and also of moisture in the soil. And if those of you who get the NASS updates Monday afternoon on crop progress know that they've started to put in now the topsoil moisture as one of these maps. This is the crop side of it. And I put the 2022 one is on the right there. The darker green this is, the more canopy is out there. And I just went back and, 2022 doesn't look like it has very much on it. And that was partly because of the dry weather we had experienced in June. I went back to a similar week in 2018, which is sort of our champion year ever of canopy development, and you can see how green it was. You can pick the cities out there. Champaign, it shows up down here. And then I went back to 2015, which was our record wet June that we had, and you can see that mess up in the northeastern Illinois that year was a lot of standing water and not very much crop. So it just gives you an idea of some of the new tools that are becoming available, and the people that work with modeling are going to have these to use. The other part of that is topsoil and subsoil moisture, and I just looked at it as it developed. And it helps me to think about what happened during this season. That center one is sort of the dry highlight, the 4th to the 10th. We got rainfall here during that week, so that helped. And the green here is, about good soil moisture, and then as it gets into the yellows, it's less. And this does not paint a picture of serious drought stress. And the drought map had sort of lit up on parts of Illinois during this period, including right here in east central Illinois. We had a severe drought indicated. And when you looked at this, and I just am showing it to you to say, we now have some tools that we didn't have before. And this is a better predictor of what actually happened with our crop than the drought map or things like that. This is just the yields, and I had the slide for another purpose, and I just left it in here. On the left shows the progression of NASS estimates of the Illinois crop yields, corn and soybeans, and they actually went up quite a bit from the August 1 estimate to the final, and we had 214 bushels per acre in Illinois this last year, which is a new record for us. Soybeans were 63, which isn't quite a record. And you can see the progression since 1990. One of the big changes for those of you who haven't been around as long as I have, and for me as well, is this steady progression upwards. You know, when I started in 1982, we had just passed the 100 bushel trend line yield in Illinois. And this year we just passed 200. And that's kind of remarkable. I told the group the other day I only take credit for 10% of that increase. But that's a joke. Don't write that down. You can see here that since 2017, when I retired, that line has been really straight, kind of straight upwards here, and that's just a coincidence. But soybean has been going up at a very steady rate as well. Most of this I put to genetics. Some of it's management, but we really, you know, management has changed a lot less than genetics have changed. We'll put it that way. And, you know, so getting these high yields, we like to take credit for what we do. A lot of it is putting those top yielding hybrids and varieties on these top yielding soils and just standing back and watching it grow. These are the nitrogen responses from 2022, being a relatively dry year. And we had a little bit below normal rainfall through the summer months, June, July, and August. Here, it was much drier than normal in June. In this part of the state, we had barely an inch of rainfall in the whole month of June. That has some real benefits to it, and we saw that these last year. And one is that our stands were almost perfect. We had essentially no standing water damage anywhere in the state this year. That's probably the first time in 41 years that I can say that, because we always have standing water somewhere. This year there might have been a little bit in southwestern Illinois. It came later in the season, but you know, we had except for the dryness and some of those symptoms, it was an excellent, excellent year from the soil standpoint. What that means in practice, and this takes a little explaining if you haven't heard me talk about the NREC calculator and MRTN, which is maximum return to nitrogen. You can see on that one on the left, these are the actual response curves that we had from this last year. So this line up here where the green circles are, that's the yield at the MRTN, which is based on all of the research, nitrogen research we've done before. And without, you know, the help from NREC and the IFCA and Dan Schaefer getting on-farm trials, we probably wouldn't be talking much about this calculator, but it's a valuable, it's our best tool we have right now to estimate what our nitrogen needs are going to be. It's inaccurate for almost every year. The way, and that makes sense if you know what applied research means. We have to base it on what we've seen in the past without knowing what we're going to see this year. What we saw in 2022, and those yellow triangles are the optimum on each one of those curves. That's where the last little bit of yield increase just pays for the last pound of nitrogen you put on. And what do you see? They're almost all to the left of that MRTN. What does that mean? We put more nitrogen on our fields than we needed in 2022. Almost universally, I would say. Because you can see those range from 100 to a little under 200 pounds corn following soybean. Southern Illinois, it's about the same story. We had one sort of outlier that's way to the right there, but dry weather that preserves the nitrogen in the soil and gives the roots maximum ability to go and take that nitrogen up is the key to high nitrogen uptake and high efficiency of nitrogen use. And it means that had we known that in advance, we would certainly be able to have used that and said, let's lower our rates. The real lesson we took from it is don't go out and put more on when it's early in the season and the crop looks really good. And that's what some people did in 2022. And it absolutely was a complete waste of money. I think I'm going to skip over this one in interest of time, but I went back and looked at some of our research results to say, what do we get when we have a dry summer? And very quickly here, we did a project a few years ago where we went out and put nitrogen on the crop for the first time at these different growth stages, all the way from planting time up to R3, which is sort of the middle of grain fill, roasting year stage, at these stages that I indicated here. So this is basically putting it on from 1st of June to first part of August, about every 10 days or 7 to 10 days. And so in a year with good rainfall that was 2016, you can see that as time went on, and these are SPAD readings, consider these readings to be, how green versus yellow is the canopy. And anything less than about 40 is very yellow. And anything above 50 is pretty green. So this is a little meter that you can go out, and it doesn't tell you anything your eye doesn't. It's just that we get a number here, so it's more scientific. But you can see what happened. As time went on with good moisture, the crop was taking it up nicely. As soon as we put nitrogen on, no matter when we did it during the season, it started to green up the canopy. That's why those lines are going up. But you can see here that in this region, they started up quickly, but they were too far behind by that point, and it could not get it back to what it needed to be. On this, in 2017, which was a very dry year, we only had 3 inches of rain, basically from end of June to first part of August, or from mid-June to first part of August, and over twice that much in 2016. You can see here that the crop canopy never got as yellow. It started up, but it started up very slowly. And why I put that in to give you to tell you that if you put nitrogen on in conditions where the soils are dry, it just sits there. So the crop had no access to it. That's why these actually continued to deteriorate in canopy color until it rained some, and then they started up. But again, they weren't able to get there, but they all are higher at the end of this at R3. Those values are higher than we had in 2016. And that showed up in the graph at the lower right there. That just shows you the correlation between grain yield and that SPAD reading at R3 at the right end, side of that. And in 2017, even though it was a very dry year, we had higher yields with late application of nitrogen than we did in 2016. And that's simply because the crop took it up better from the soil and it kept it. So, it's a delicate thing between the soils. The organic matter that's in the soil is producing nitrogen through mineralization, and the crop is taking nitrogen up. And if we have dry conditions, not too dry to wreck the yield of the crop, but dry enough to preserve the roots and to preserve the nitrogen that's there, it's highly beneficial. I'll show you just a few other things very briefly. We've been running, Dan Schaefer and I, IFCA, Dan is here, we've been running trials the last 4 years with nitrogen put on different ways. So all of these on the table on the right had 150 pounds of nitrogen put on in these different ways. And the number down at the bottom is a critical one to look at. That's how much nitrogen it took to optimize yield, or basically to maximize yield in the trial each year. So we had a nitrogen rate trial built into this study. You can see the nitrogen response over here on the left. This is the optimum in 2022 was 111 pounds of nitrogen. That's all it took to maximize the yield. How can so little nitrogen maximize the yield at about 200? It's no big mystery. It has to come from the soil, and it comes from the organic matter in the soil. And the crop took up all of the organic nitrogen probably made available. What it means is, and you can see this in the list of non-responses here, statistically these don't even separate, except one of the treatments that yielded a little bit higher was significantly higher than the check, which is the 150 injected at planting, the top line. But none of the others made a difference. If you had plenty of nitrogen in the 150 and we needed only 111, it didn't really matter if it wasn't very efficient at getting there. It was fine. And that's partly because the soil supplied so much. You can see there that the yield without nitrogen, it's an important measurement we get every year, was over 100 bushels. And so nitrogen just enabled it to go above that. And we'll say more about that later, but I put down rainfall at some of the others. You can see 2021 had a very high requirement for nitrogen and lots of differences among treatments. That's the way where you can separate this. The problem is, what I'm pointing out here is that the weather conditions and how the crop is responding is so influential on how it responds to nitrogen with timing, rate, and form that, we don't ever come to a conclusion that says, well, we'd better do nitrogen differently than we're doing it. And that's just going to be the case. We had a lot of nitrogen in the crop at maturity this year. Farmers kind of rejoice in that, they think, well, it really filled out grain, and it did do that. We had larger than normal kernels, but there weren't as many of them as we would have liked because of the dry weather. And those two things were somewhat related. I think the nitrogen was in the soil, it was concentrated in the water that was taken up after we did get rainfall, and the crop was very well nourished with nitrogen right up to the maturity. We sampled these on the day I took this photo was taken after these should have matured. And they didn't look mature. The leaves are still all green. So the amount of nitrogen we removed in the grain here was smaller than normal percentage of the total nitrogen that the crop had in it at that point. I put the total plant nitrogen there as 227 pounds per acre. That's about 1.1 pounds per bushel of grain yield. And that's not a favorable ratio. Not favorable in terms of fertilizer use efficiency. It's still favorable in that these maximize the yield that they could make because the tissue stayed green. The downside of it was, and every farmer can probably tell you this, that the crop stayed green and it dried really slowly. And I think that's because there were sugars in the kernel and they keep it from drying down very fast. So it was a nitrogen-rich season this last year. We had a timely start to mineralization. The soils were warm at planting. Planting didn't start especially early, and very little nitrogen loss from soil. Things like planter-applied nitrogen, which some people I think that gives them yield boost in 2022 may not have given very much. In-season N applications on the surface, and we do some of that in a lot of fields in Illinois, probably was delayed in reaching the plant. The fact that there was little or no N deficiency meant that probably didn't do much harm. It also meant that nitrogen probably didn't do much good in many cases. There were unnecessary, we have no way to know that, but even people that were using a proper rate and kept some of it back until the corn was this high, very likely could have skipped that last one and been fine. and we won't say too much else. Relatively high yields with no or low N fertilizer this year, and N rates needed to maximize dollar return were less than MRTN, as I said to you. This is what the calculator tells you if you put the numbers in today with $6.25 per bushel of corn for 2023 and 94 cents per pound of nitrogen, which is our UAN solution at $600 per ton. And it's the current version of the calculator. We'll update that with the new data here in the next month. It's not going to make very much difference. The MRTN rate, remember, and I put a note down there, it's the total nitrogen applied, including that from MAP and DAP, planter applied, herbicide carrier, etc. The end price that we use to calculate it should be the price of the last form of nitrogen that we apply. It's the one that tops off the rate, in other words. And you'd say, well, that doesn't make sense. Why wouldn't it be all of the nitrogen? Well, you already put most of it on. By the time you decide that you put that last one on, the price of that last one is the flexible part of that. The rest of it simply sunk cost at that point. So we don't expect people to look at these and say, well, Central Illinois corn falling soybean 165, that's what we should use. We hope somebody that's using 230 says, maybe I don't need that much. And the NREC calculator has moved in the last week. It's just in the process now. PAC Interactive at Monticello has been the ones to sort of regenerate the NREC calculator. It looks very similar to the previous one, but you will be happy to know that it is no longer an Iowa State website. Yeah. I think NREC paid good money for that. Not really. We all wanted to move it off. It was there because John Sawyer, my colleague at Iowa State and a U of I grad, he's the one that came up with the website or the calculator on the website. The idea was one that sort of he and I and Howard Brown and a few others hatched back in the mid-2000s. There's better images, and they're the same calculations. Now, N-rate verification is something I've introduced in the last year. We think that, we've had a wonderful run with these full rate trials. And you see an example of an aerial shot that Jason Solberg took of one of these trials in the field. And these are a wonderful thing. This is, if nobody's done one and would like to, there's still time. And Dan has done a great job of finding cooperators, and this is what these look like. The light colored strips are one thing that farmers don't too much love about these, although they do get a payment. But because of that, and because of the need for more of these and the need to make them cheaper, we've decided that one way to do this is to do single rate or two rate strip trial. And we'd like to get these in lots of fields if possible. The concept is very simple. You use whatever rate you use in the whole field is one rate. And then depending on what that rate is in the strip, and it's wide and needs to be wide enough to take a combine header off of each side and then one in the crop next to it, that in 50, 60 pounds different than the whole field strip or the whole field rate. And then we just put those out, and that's all there is to it, and then get combine yields from them. And we think this is the way we'll move nitrogen forward. So we have a good basis right now. The N-rate calculator, I think, is sound. People can argue with it and say, well, my field's different, but nobody actually has an idea that's the case. And we have hundreds of trials in that calculator. You saw when I showed that, I think there are 290 corn falling soybean in central Illinois. 290 trials go into that database. And this is just a way to average those results, crunch them together. We tried this. We've started some of this. We did some last year. I've got 6 of them there on the left-hand side that we laid out here in east central Illinois mostly. And you can see there our average medium, I call it a medium rate, not a low rate. So we'll call it you can use whatever term you want to, but it was 186 which would be a pretty good rate. I mean, that's above the MRTN, but it's not drastically above it. And the average in the high strip, in the high rate then, and most of these, that was in the strip, not all of them. So if your whole field is at 240, the strip would have to be less than that to meet the idea here. But on average, you can see the orange bars are the yield change, the blue bars are the net income change without any cost for application. Most of these would not have a cost for application because they're simply put, lowered at the time that, or raised at the time nitrogen is being put on. So adding an average of 57 pounds of nitrogen increased yield by 1.6 bushels per acre and lowered the net using those prices there by $43.41. And this was a year, you saw me talk about it, where we didn't need lots of nitrogen. Every year is not going to be like this. But this is the kind of thing we need. One of the difficulties we have with nitrogen is if you tell a farmer who's been using 230 pounds per acre that they could get by with 180, their immediate response is, how would I ever know that? How is it safe to do that? And this is, we hope, would give some real visual evidence and yield monitor evidence to people that it works to do that. We don't have to depend just on these. We also have those 9 end response trials I showed you. I just drew a vertical line in those and calculated the yield at those 2 lines. One's 175 pounds per acre and 230 is the other. And the yields were basically identical if you average them where those vertical lines cross the yield response curves. Adding 55 pounds of nitrogen actually lowered average yield by 0.2 bushel. One of these trials actually had a yield go up and then start down, and that's why it's lower. And the net was lowered by $53. So we don't, not every year is going to be like this, as I said, but this is the kind of information we really need to see coming. Well, let's move on. Can we learn to sense corn nitrogen status and fertilize accordingly? And this has been a huge issue and a huge amount of work done on this in the last 20 years. Once we were able to sense canopy, people just automatically said, let's put more nitrogen where the corn's pale and less nitrogen where it's darker green. And we were, I think most of us were really, truly believing that that would work. This picture sums up why it hasn't worked very well. And that is, these soils that are so productive with higher organic matter, with mineralization, they produce a lot of nitrogen. This photo is one I took in 2016 down on South Farm. The left-hand side of this had 0 nitrogen applied. The right-hand side had 200 pounds of nitrogen. This was taken about June the 20th, as I remember. What would your device have told you if you were sensing on the left-hand side where you hadn't put nitrogen? Would it tell you to put a lot on there? Absolutely not. And that's the problem. We can match canopy color to yield when N availability varies due to N rate. So we can, if you wait long enough, these colors will show up. I suspect a week later, 10 days later, the one on the left was paler color. But how long can you wait? And that's a problem. The timing aspect of it is critical. Is it already too late to get N into the plant when we see deficiency? And in most cases, we think the answer is quite likely, yes. It seems unlikely we're going to learn to do this in rain-fed agriculture. In irrigated corn, it works pretty well in Nebraska. They've done it. Stay tuned. Nobody's given up on this yet, but there were whole companies formed up to advise farmers, take maps, aerial maps, say, put this amount of nitrogen here, and I don't think any of those really exist today. Well, how about variable rate nitrogen? Very quickly, we can do it, sort of. We did a simulation here where we had 10-year studies at 4 sites. And you can see their initials there. And so based on over 10 years, we could calculate what we thought was a pretty good, MRTN rate going forward on those sites and say if this would be a good rate to use next year on those sites. And so we simulated this and said if you had a field with 10 acres of each of those, quote, soil types or those N responses, and you somehow knew that, and you put on what it needed instead of just a uniform over the whole thing, how much benefit would you get? And the answer is down there on the bottom line. So variable rate nitrogen, took 1 pound less nitrogen and yielded 2/10 of a pound more, 2/10 of a bushel more. All the data, which means we just calculated a uniform rate of nitrogen for across the whole field using all of that data, was barely any different. And that means using that N rate uniformly instead of the N rates that you see these 4 up here for each appropriate part of the field, and they're pretty variable, gave us almost no benefit in terms of net. If we somehow knew exactly what every acre out there needed before we started, and I'm not going to stand here and say we'll ever know that. But so I took all of the data here, 40 site years of data, and calculated, 1 for each acre, and said, well, if it acted just like that again, then how much would we benefit? And then those numbers look a lot better. The real problem is we don't know how in the world you'd ever set those before the season and know where you are. Variable rate work has been done in fields a lot. What they have found, and I would just sum up as saying, yes, optimum nitrogen rates vary across a field every year. The problem, the optimum nitrogen rates do not stay in place, and they move around from one year to the next. I just put in a word about Pivot Bio's Prove-N. This was some research from different sources this last year. Other states did some as well. The company has been very aggressive, as you know, and they're selling this pretty widely with ads saying that their material provides 40 pounds and you can put it on the seed of nitrogen. The emphasis is on the amount of N in plants during vegetative and early reproductive stages, less on grain yield. I'll just show you one slide from this. On the left is a trial we did at Monmouth this last year, and you can see we did these full rate trials with and without the material, thinking at the low rates is where we should get a boost in yield. And on the right is averaged over 7 sites, including this one on the left, with rates from 100, 50, 100, 150, and 200. And you can see there that we really didn't get a big boost of any kind in yield. We don't know exactly how that works. It's certainly, nobody can prove that a product like that doesn't work. We haven't seen enough yet to tell us that it's going to pay for itself, but we'll have to wait and see. A lot of it is going out. I just threw this one in because I saw it a week or two ago. This puts a shot of nitrogen right on the seed instead of between the rows, between the seeds down the row. I thought it was kind of, the John Deere has brought this out with their high-speed planter. One question I did have about it says fertilizer applied between plants is wasted, and I kind of thought roots would get out there and get it, but apparently I was wrong. But it's just one of those new things. And the last thing we have, and Dan Schaefer put out copies of this nitrogen chapter, Nitrogen Management for Corn. It's agronomy handbook revision that I worked on, and be sure you take a look at that and let me know if you have comments or questions on it. Finishing up, we believe a current N rate database is the sound basis for N rate recommendations for the next decade or more. We expect these N verification trials to provide immediate assistance in helping to lower N rates where that is appropriate. And we expect that if they can be spread widely, they may be a way that helps us fine-tune N recommendations going forward. I think it could allow us to provide MRTN values for smaller regions and for different soil types and topographies. That's ambitious, but modeling, and I work some with Caillou Guan's group, and it's exciting to see what the potential is for that. If we pair that with periodic sensing and modeling, fly over these, see when the deficiency occurs, I think we could use it to adjust our rates in season. But that's a research question at this point. Thank you very much for your attention, and I again failed to get us back on track.